This is Mark Anderson for Kellogg Community College, and we are about to take a quick look at ellipses that have centers at the origin. To look at their equations, we're just going to look at, again, these are all at the origin, so they're not going to have any h or k shifting like we did with circles. So the equation of the ellipse is x squared over a squared plus y squared over b squared equaling to 1. And our x-intercepts will be the points a, 0 and negative a, 0. This is taken from the square root of a in the denominator of the first fraction. And our y-intercepts will be 0, b and 0, negative b. And that would again be from the square root of b in the denominator of the y squared. So what we're going to do is list our x and y intercepts for these problems, and then I'll draw the ellipse on the graphs below. What you may want to do is you may want to write down these intercepts, and then as I erase them to move to the bottom of the screen, you can then take a look and see what they were. And I'm already off and writing, because if I look at the square root of 4, that would give me 2 and negative 2. And then if I look at the square root of 9, that would give me 3 and negative 3. And these would be my prospective x and y intercepts here. Now for this problem, it would be 4 and negative 4. Whoops, I should have negative 4, 0. Sorry about that. And then over here we have 0 and 7, and then here 0 and negative 7. So you should write down these intercepts, and we are going to graph them in just a moment. Now it does, on a quick note, if you ever do have a denominator that isn't easily square rootable, the best thing to do is to turn those into approximations or decimals, and then, plot those decimals as to how far they are away from each other. Alright, so here's what we got. 2 and negative 2 for this first ellipse. Those are the x-intercepts, and the y-intercepts are 3 and negative 3. Now since these are centered at the origin, we don't need to actually plot the center here, or there are some more advanced concepts of ellipses you can deal with, like foci and stuff like that, but we're just going to deal with just some simple freehand drawing of these ellipses. And a lot of people will think that they're just ovals, which is fine. This is the quick and easy way to draw these out. Our next set is going to be with 4 and negative 4, so here's 4 and negative 4, and then we have 7 and negative 7. Alright, and then we're going to make our nice smooth arc. Doing one quadrant at a time is probably the best way to get nice ellipse curves here. Try not to make it look like an egg, but there we go. That's about, it's pretty good. It's pretty good. That is our quick drawing of ellipses that have the center at the origin. And again, to remind yourself that this equation, x squared over a squared plus y squared over b squared, is equal to 1. And in the next 2 sections, we're going to talk about different types of hyperbolas that have centers at the origins. You're going to see a different operating system here. You'll see a subtraction and maybe a different ordering here. But thank you for watching this very quick video about very easy ellipses with the centers at their origin.